All right, well, we're starting a brand new unit over ratio, proportion, and percent. So first lesson, 7-1, what is a ratio? It is simply a comparison of two quantities. There have to be two, and I want you to list each of these examples. So I could compare saying there is one teacher per 15 students. That's a ratio in words. And I'm going to write two more in words, and then we'll write the notations for them. We could compare 5 points per problem, say on some quiz. Or we could compare 3 girls to every 2 boys. So those are some comparisons in words, but they're not exactly ratios, but ratios can represent each one of these. And there's multiple ways that you can write a ratio. So I don't have room, but if you have room right here where it says notations, that's really where you could put another ABC and then write these down. I'm going to squeeze mine in over here to the right of each one. So one teacher per 15 students. I could write it just using the word 2, 1 to 15. I could write it using a colon, or the most typical way that we write it in mathematics is a fraction, 1 over 15. So if I don't specify, you can write it any one of the ways that you wish, but you're going to find that the fraction form is most convenient. I'm going to erase those, and let's do the second one. 5 points per problem. So you might be thinking, well, there's only one number in there. Well, really, it's like there's a 1 slid in there. It's 5 points per one problem. So you could write 5 colon 1. You could write 5 in the word 2, 1. Or you'd write a fraction, 5 over 1. This is one of those examples right here in particular where you would not simplify this fraction. If you simplify it, you would just have the number 5. The number by itself is not a ratio. A ratio has to compare two quantities. All right, let's do that last one. So I will put that one right here. So I could say 3 to 2. So I could write 3 over 2, 3 to 2, or 3 colon 2. All of those could be read 3 to 2. Typically when we see 3 over 2, we say 3 halves, but if you're talking about a ratio, you would say 3 to 2, no matter which way that it's written. So let's take an example where we have to actually come up with the ratios. And you do want to simplify the ratio, but keep in mind that the ratio has to have two numbers in it. So it says, if the following red list, that's all this over here, represents the number of students playing specific instruments in A3A band period, find the requested ratios in fraction form. So it specifies. So when it specifies, you need to write it in that form. I would do it even if it didn't say it all. Most likely I would write it in that form. All right, so trombones, trumpets, clarinets, flutes, and saxophones. So clarinets to flutes. clarinets to flutes. There's 5 clarinets and 7 flutes. So that would just be 5 over 7. 5 to 7. Trombones to trumpets. 4 to 6. Now 4 over 6 simplifies to be 2/3. So I'm going to write 2/3 over there. Saxophones to clarinets. That's 3 to 5. That doesn't simplify, so I'll go ahead and just write 3 over 5. I didn't leave much room over there. Now, this next one's a little different. See how I underlined trombones and trumpets? So it's clarinets, and then this trombones and trumpets is all together. So trombones and trumpets together, that's 4 plus 6. And clarinets is 5. So that would be 5 over 10, which simplifies to be 1/2. Then we have flutes to all other instruments. Well, let's just total up this column. We've got 10 for the first two, then 12, so that's 10, that's 12, plus 3. So 12 and 10 is 22, plus 3 is 25 total. So flutes is 7, all other instruments, oh, actually we have to change that. We have to add up all other instruments. So if we leave out the flutes, this is everything altogether. We only want 7 to everything. We have to subtract 7 from that. That'd be 18. So it would be 7 to 18. Everything, there's 25 altogether. And then it wanted the total instruments. Here's where we're going to use that 25 to clarinets. So 25 over 5. 25 over, oops, we're going to have to simplify that, so I'll scoot over. 25 to 5 would simplify to be 5 over 1, not just 5. And I got another example here. We're comparing 6th grade advisors to students. So the ratio of 6th grade advisors, which there's 8, to 6th grade students, I'm not sure I have the number right here, it's something close to that, is 8 compared to 91. The ratio of 6th grade students to 6th grade advisors, so that reversed it. So the order that it's written is very important. Whatever comes first would be on top here. So since students to advisors, it would be 91 over 8. 91 is not prime, but it doesn't have any common factors with 8. Second part of this lesson, 7.1, is learning about the term scale factor. A scale factor is just a multiplier, and scale factors used in different ways, but here we're talking about a multiplier used to yield an equivalent fraction. Well, really, when you yield an equivalent fraction, you're not really multiplying by anything. You're multiplying the whole fraction, by the number 1. But here, to get from 4 to 3 and 5 to 15, you multiply top and bottom by 3. So the scale factor there is 3. The second one's the one that's a little harder. If you start bigger and you go smaller, you're not really multiplying, you're actually dividing. So here I'm dividing by 3 and dividing by 3. Well, remember, dividing by 3 is the same as multiplying by 1/3. So that's why the scale factor is 1/3. So I wrote a little note, if you scroll down underneath this table we're about to fill out. It's just a little help to remember. If you start with smaller numbers on top and bottom and they end up being larger when you're writing an equivalent fraction, the scale factor is whatever you multiply by, so it's greater than 1. If you start large and you're going smaller, that means you're dividing the top and bottom or multiplying by a fraction. So the scale factor would be between, this means between 0 and 1. So these scale factors would all be fractions. And by fractions there, I mean proper fractions, okay? Not greater than 1. So we're going to write the scale factor for each of these going both directions, like from A to B and then from B to A. So we can kind of get these stacks down here kind of straight as to which way it is. Excuse me. So let's start with the first one. Let's just do the whole A to B column first, and I'll show you a trick to getting it the other way. So if I'm going from A to B here, think, what is happening to top and bottom? Well, we're multiplying by 10, so the scale factor is 10. On the second one, to get from here to here, we're dividing. So I'm just going to write here, we're dividing by 2. So the scale factor when you divide is the fraction. It's 1 over whatever you're dividing by. The third one, ask yourself, what are we multiplying top and bottom by? Well, 7. So 7 is the scale factor. And the last one, the numbers are larger going to smaller. So on that one, you might actually have to do a little calculating if you're not sure. But we're actually dividing by 25 to get there. Dividing by 25. Let me write that out here. So that means you're multiplying by 1 over 25. So if you want to reverse it, you really don't have to do any work. If you reverse it, this is just going to be the reciprocal of A to B. So we reviewed reciprocal back in Unit 4. So the reciprocal of 10, 1/10. Reciprocal of a half is 2 over 1, or 2. Reciprocal of 7, 1/7. Reciprocal of 1/25 is 25. And that, everybody, or as Father Robert says, my friends, is the conclusion of 7.1, ratios. Have fun with the homework.